Recording. This is the Chapter 23 capacitors part, homework solutions. We went over most of these in class, but I just want to make sure you have this available to you to correct before your test. Question 26 was asking about, hey, that's my principal. Say hi to Mr. Campbell. Anyhow, one was 3 capacitors in series, 2 was 3 capacitors in parallel, 3 was 2 capacitors in parallel with 1 in series, and the 4th circuit was a parallel circuit with 2 capacitors in one branch and 1 in the other branch. So this is pretty easy. You simply do 1 over C plus 1 over C plus 1 over C. That's C over 3 is your total capacitance. Here you just add them up because they're in parallel. Here you add these two up, so I get 2C, and then I put 1 over 2C plus 1 over C to get the total, and then I flip it again. So that's 2/3 C is my total capacitance. For this one, this would be C over 2, and this would be C down here. So C over 2 plus C, 1 over, C over 2 plus C gives me 1.5 or 3/2 C. That's the total capacitance. So I end up with capacitor 2 is greater than 4 is greater than 3 is greater than 1. Should be pretty easy that this is the biggest and this is the smallest. These two, a little trickier to do. All right, we've got a question here which has a switch, 2 identical bulbs, and a capacitor. Immediately after the switch is closed, both bulbs would glow pretty bright because essentially there's no charges on this capacitor, so it's acting like a circuit with just simply 2 resistors as the bulbs. They'd be the same brightness as each other. It doesn't matter whether they're before or after the capacitor or before or after the switch because it's a series circuit. The brightness would decrease over time as this capacitor fills up with charge. So the current would decrease, and at some point it would stop entirely because the capacitor would be completely full, and the potential difference across the capacitor would equal that of the battery, which means no current can flow because there'd be no potential difference between the right side of the circuit and the left side of the circuit. For problem 41, asked to figure out the total capacitance. These two are in parallel, so we add them up. 20 plus 60 microfarads is 80 microfarads. Then this equivalent 80 microfarad capacitor is in series with a 10, so it's 1 over 80 plus 1 over 10, and that gives us 8.9 microfarads. For problem 42, you're asked to figure out the total capacitance as well for part A. So these two I'm going to handle first. That would be a 3.5 microfarad capacitor. That equivalent capacitor is in series with a 4 microfarad capacitor, so we get a total of 1.87 microfarads. This part B is asking for the charge, the total charge that would accumulate on this after the capacitor has been, basically the capacitor has been charged for a while. So we have, this is the total equivalent capacitance of the circuit. This is the voltage of the power source. So essentially we multiply those two together and get the total charge that will end up being on those plates. 2.24 times 10 to the negative 5th coulombs. This one we went over in class. I really like this question because it basically switches from a circuit, which is a capacitor circuit, to when this switch goes over here. This is now essentially a series circuit with a resistor, and the capacitor is acting like a power source. So the voltage on this capacitor would be 9 volts at time 0, because I know that it's been hooked up to the battery for a long time. So if I want to find out the charge at time 0, that charge is the capacitance multiplied by the voltage, so that's 1.8 times 10 to the negative 5th coulombs. That's the same equation I used up here. To find out the initial current, I take the potential difference divided by the resistance, so when that flips, remember this would be at 9 volts, this is 50 ohms, so that's 0.18 amps. And after a long time, when the switch is moved to point B, the charge in the capacitor would run out, and the current would also end up being 0. So again, hopefully these make sense and you're able to understand how capacitors act in circuits. We will have a capacitor lab as well.